Okay, depends on whether you can make it. Well, hi everyone. Welcome back to our series of programming competitions training. This will be, if I'm not mistaken, will be the last recording for this series for the USACO programming training. Okay, so today we are going to look into one of the very interesting material shared on the USACO website. It's about binary numbers. It gives us ideas on how we should play with the very fundamentals ideas of computers program, which is 1 and 0. Okay, so let me share out my screen. Okay, so we have a lot of we dealing with numbers daily, and then in the computers it will go up to very simple status, whether it is either a 0 or a 1 status in the computer's world, right? And from this 0 and 1, it covers a lot of different representations. Okay, so like for instance, I give you a number of 10. So actually, if you want to represent a number of 10 in the binary world, so how it should look like? It should be something like k 0 0 1 0 0. If let's say this is an 8-bit, okay, right? Let me see. Oh, nope, this is not. I think this is. Okay. 1, 2, 3, 4, 5. No, I think this is. Sorry. Okay, 64, 32, 16, 8. Yep, this is how we represent a 10 in the binary numbers. Okay, and it's a combination of a series of 0 and 1, or we call it a bit. So in this case, actually we are having a byte, which is an 8-bit representations that we can use to represent a number, right? Okay, so this is one examples here. So actually what we want to, let me see. Wait. Yep. Okay. Sorry, let me add the mistakes again. Okay. So this is 4 3 4 2 4 2 1 4 2. Okay. Yep. Okay. Thank you very much. Okay, so this is the this is how we represent number 10 in binary form. So how from these combinations of the binary bits, actually we can come up with different types of representations for all the characters and all the different value that you can. Sorry, you might heard a little bit of noise here because now we are doing constructions in our building. Okay, well anyway, we should continue here. So actually, this is a very simple form of representations, and what we want to do with this, okay, we are not really interested in how we should represent it in different form, how they can use it to code different characters or different representations. But what we are more interested here is how we can do some very basic operations on this bit number. Okay, in the programming competition skill, one of the very useful tools, the data structure, is how you organize the value in a big mass like this, where you can do a very fast calculation and a fast manipulation. We'll talk about what kind of applications we can do with this simple representation, but let us just talk about a very simple idea first. What are the basic operations? Of course, the very first operation is we study logic, right? So when you have two values, you have a 0 and a 0. If you try to apply an AND operation, where's my AND operation? Okay, we try the AND operations. You know that this actually will give you a result of a 0, right? So same thing we study if you have anything others operations, like for instance, okay, we'll give you a 0 as well. So these are very fundamentals AND operations that we have learned maybe in our high school time, right? So another operations beside the AND is only valid when both elements on the left and the right are true. Then only it return you a true value. Okay, so same thing if you have 0 1, you give you a 0, and then only when it is 1 and 1, then it will give you the value of, right? So this is a very basic AND operations. Okay, and another operation is called an OR operation. So what is OR operation? So when either one of the value is true, then the answer is true. So if this is the case, right? So this is two very basic operations. So what can we make apply these operations in the numbers here? Well, one of the very typical AND operation is if given the numbers, okay, when I convert it into a binary representations, I want to know whether the particular bit is already either is 1 or is 0, or we say it's on or it is off, right? So if you get this number, if you get a number 10, and then you AND it with another number, let's say number 1, okay? So if you try to do this 10 and 1, so what happened actually is you'll get the two representations. Okay, and then they will try to apply the AND operations over here. Of course, you get answer is very obvious. You get the zeros here, right? So it means that at the first bit of number 10, actually this value is 0. So the AND operation allow you to very easily quickly figure out whether the particular bits is be turned on or off. Is it 0 or 1? Okay. So and then what is useful? The usage of the OR operations again in the problem solving. Actually, what you can do is the OR is very useful if you try to change some of the values of the representations. Let me see. What else we are talking about? Okay, yes, another operations which is an XOR. Okay, an XOR value. So if let's say all the value for the OR operations, if you get this two representations, you get a 10 or with a 1 value. What actually you will get is you will try to apply these two together, 0 and 1, or where you will get a value of 1, you can turn this into a 1. Okay, so actually is to turn the bit on and off. This is to turn off it, and then, sorry, this is to check, turn it on, and this is to check whether the bit is on or off. So another operations which is also very useful is called an exclusive OR, or make it simple, an XOR. Okay, so in the programming, this is represented as a pipe, and this is as if I'm not mistaken, as a hat. Okay, so these are the basic operations. So what is the result of applying XOR onto the value? So what you will get is if you have a sorry. Well, somehow I think using a whiteboard is much easier. Well, anyway, let us continue over here. Okay, so for an XOR, if you get a 0, you XOR with a 0. So this will return you the result of a 0. Okay, so if you have a 0, you XOR with a 1, result 1. And then if 1, you XOR with a 0, then you return a value of 1 as well. If you get 1 and you XOR with 1, then you get a 0. So the behavior of XOR is it will only return 1 if the two are different. So which means very interesting. If I give any numbers of this, okay, let's say I want to change the value. One of the problems I still remember is to represent the light on a 2-dimension on a matrix, and then you try to flip all the values, and then where you can do a very simple operations to flip this value is to apply it, XOR it with 1. Okay, let's say if you XOR this value with 1, so what it should produce is 1 0 is a 1, 1 1 1 0 0 is 1 1 is 0, 0 1 is 1, 1 1 is 0. So actually this, if you compare, actually this is the flip of this value. Okay, so it is quite useful in the sense of the behaviors that actually one can use to check whether the bits is be turned on and off. The other one use it to turn on the particular bit, and the last one, of course, to flip all of the values. Okay, so well, maybe let us bring it into the code. Oh well, before we continue to the operations, so we can turn the value on, can turn the value off, and then we can also do some other simple manipulations. Like for instance, we can shift the bit to the left or to the right. Okay, when I say shifting it to the left is, let's say giving number of 10. Okay, when I shift it to the left, so means I get all the single bits, I move it, I shift it one place to the right. Okay, let's say I want to shift it to the right. So what I will get is this is the result. Now 1 is over here, 0 is over here, and 1 is over here. So actually, what is the consequences of shifting everything's one bit to the right? So if you calculate back, this is the value of this is a 5, right? So this is the 4. So you shift it one place to the right. So once you shift it one place to the right, actually you are dividing it with 2. Okay, because of every one bit here is represent a 2 over here. So means that if I continue to shift it again, okay, this time I try to do it on the other way around. I shift it to the left. Okay, so if I make this is what happens if I make a right shift. So if I want to make a left shift this time, okay, so I will still have 0, 0 and 1, 0, 1, 0, 0. Okay, so what is this value? So this should be 16 plus 4. This should be a 20 if I'm not mistaken. Right. So this is a left shift. Okay. So when you shift it the other way around, actually you are multiply it with 2. Okay. This is only shift for one places. You can shift for many places as well. So this is shifting the bit, and then this is the 3 simple operations. So now if we try to bring it into a C program, into a program, so what it will look like. So let me bring out my another screen. Okay. Okay. So first of all, this is a very interesting. I need to display it in a better way, right? So I borrowed someone's a very nice piece of code written by the Halim's brother in this competitive programming series book. So where this function is giving any numbers, it will print out it in decimal point and also print out in binary numbers. Okay, for instance, if I give a number of 34, and then this is what it should look like. Okay, yeah. So first of all, we mentioned about a few operations just now. So what if I make a shift over here? In this case, I try to shift it one place to the left. Okay, so the consequences is I move 1 over here and then 1 over the other side. So actually you try to multiply it by 2 in this sense. Okay, so means that what happens if I try to shift it for 2 places? Okay, actually you are trying to multiply it by a 4. Okay, because 2 bits multiplied by another 2 bits, so it's a 4. So same thing, you know, if you continue to do it, it will be shift another place, shift for 3 places, you will multiply by 8, shift for another place, you will multiply by 16, and so on and so forth. So these are very simple operations that you can apply over here. Okay, so just now we also mentioned about the bits checking whether is it positive, is it been turned on or turned off. Okay, so besides doing the shifting left and right, another operation is you can check whether the particular bit is been turned on or off. So you can do that using this very simple operations here. Okay, sorry, it should be this small letter of S. So if I want to know whether the first bit, okay, whether the first bit is been turned on. Okay, so whether the first bit is been turned on, so actually I can apply this on operations here. Okay, so this should return a value if let's say it's 34, and we know that 34, the first bit is 0 over here. So if I apply this operation, then it should return a value of 0, right? So this is what you can use the AND operators to check, and also you can also try to set the bit itself. Like for instance, I know that here the value is 0 now. If I want to turn on this particular bit, So it means that I want to turn it from 100010 to 100011. So you can try to audit. Let me see, where's my pipe? Give it a 1. Okay, so now you should see the result like this. Okay, so from 136, now I turn the first bit on. Okay, so now the new numbers is 137, right? So this is the all operations. Well, if you want to make it a more fancy, like for instance, I don't want to turn just the first bit. Maybe I want to turn, in this case, this bit. Okay, the third bit here. So actually, what you can specify is you can specify to shift this bit to your right first, and then before you apply concept. For instance, like this. Okay, first I want to shift one bit, but I want to shift it to the place. Okay. Oh, sorry. Overdo. So I should shoot for 2 instead of 3. Okay. So instead of changing the first bit, now I'm changing the third bit. Right? So the consequence of it is I'm adding 4 into this number, so it becomes 140. So it means you can use it together for all these kind of operations here. So we see how we can use the shifting, we can use the is and the all. Well, maybe the next thing is whether we can flip the value. All right. Okay. So let's say I have a value of s over here, and then I want to. So now the value is 10001100. So if I want to flip the value, so which will return become 011100011. In this case, what I want to apply is I want to apply an XOR operations over here with let me see what I want to apply with. I will apply it, depends on which bit I want to change. In this case, okay, just now is when I use the OR operators here, I turn on the bits over here. But now, instead of turning on and off, I want to flip this value so that this value become a 0, right? From 1 to 0. So same thing this time. I want to apply my map over here. So I want to turn on this particular bit. Okay, so this is what it will happen. Okay, so this value has been flipped to 0. So maybe perhaps you're wondering, well, can I straight away flip the entire rows? Yes, you can do that. Okay, so this is roughly how this thing can be used on the basic operations of the bit maps, shifting and then try to apply different models. Well, maybe the next thing you will ask, well, is it very useful? How useful it can be? I give one scenario over here. Let me bring back my. Oops, sorry. Did I press the wrong button over here? Okay. So if I give you a string, let's say a string of A, B, C, D, E, F, G, right? And I ask you to try to reverse the string. Of course, if you are familiar with all the libraries in Java or in C++, you can easily reverse a string. So the reverse actually it will be right. You can reverse this string very easily. You just, if you want to use a very simple primitive, you're just using a loop, and then from the first value you try to swap it with the last value, and then the second character swap with the second last characters. Then easily you will get it. So, but if you another way is you turn this one into binary form, that actually you also can do an easier way, which is, okay, I will show you this ideas over here. So when you get an A, you convert into a binary form. Okay, let's say we use back the, let me see. So what is the value for A? A should be 64 in binaries. Okay, A should be 61 or 62. The character set. Couldn't remember now. But anyway, so what you want to do is you get the A value over here, and then you apply an XOR function, okay? And then the next step is, let me give you the pseudo code over here, okay? So if let's say I want to do the swapping, the first swapping is you create a, let's say I want to swap the place of here with G. Let's say I use an array to swap it. So you roughly need to copy the values of A, which is, let's say the name of this array is an A, the first locations, and then with the 1, 2, 3, 4, 5, 6. Okay, you want to try to swap the locations of this right, where is the last one? A6. Okay, so this is what you will try to do, right? If you want to swap the place, okay, using a loop and then try to replace all the characters and then easily you can find it. Yep, no problem. But now you're using a one additional character space. If you want to make it even a simple, easier, actually what you can do is, well, you know this value, right? You can access a value. You can apply an XOR. So it means that you get this value, XOR it with a 6. Okay, in this case, or you can make it, you can even simplify this. Okay, get it XOR with 6. Okay, so what you want to do next is, for the 6, you XOR it with a 0. Okay, so now you will actually copy the values of A into G. Okay, and the last thing is you want to do is reverse it back. You want to copy the G into A. So if you try to run this, then you will know actually this is one of the coolest ways to do a very fast reversing. Okay, so what else is useful over here? So if you look at the text on the USACO website, it gives you some ideas about the basic shifting, and even it go down to the advanced bit manipulations. Okay, turn to the very last part of it. You mentioned about how you can extract the lower speed, how you can create a mask for all these operations. So these are some of the basic things you can play with when you play with the bits. Okay, I think that's all I want to say. Okay, well, next thing is try to put it into the code and then see whether you can implement a very fast string reversal function. Okay, let me go back here. Well, I think that's all from me today. Thank you very much.